A warm welcome to all of you. My today's presentation topic is experimental one, that is preparation and submission of Phenytoin. So let's start it. The prerequisite of this presentation is to provide an understanding about the principle of synthesis of Phenytoin. So now let's move to the next slide. So what is the today's objective of this presentation? Is to prepare and submit Phenytoin and report its percentage yield and their melting point. So let's do it. So today's experimental aim is to prepare and submit Phenytoin and report its percentage yield and their melting point. And what are the glassware or chemical required to do this experiment? In a glassware, you required glass rods, measuring cylinder, conical flask, heating metal flux condenser, water bath. These are the various things that you require to do this experiment. In a similar way, chemical like benzene, urea, sodium hydroxide, alcohol, these are the various chemicals that you required to do this experiment. Now let's talk about their theory, or you can say the principle. As you all know, the phenytoin is anti-convergent drug, or it is primarily utilized for the treatment of tonic-clonic seizures and focal seizures. And it is available in market in a different name like diphenylphenetoin and dilatin. So these are the among synonyms that we all know these phenytoins. And their chemical property, like they look like a white precipitate or white crystalline substance, and it is easily soluble in a polar compound like ethanol, methanol, and it is also slightly soluble on ether and chloroform. So these are their properties that you can write on this theory portion. So similar way you can write their medical uses, like it is primarily utilized for the anti convergent treatment. So now let's move to the next slide. So this is a schematic or chemical representation of this synthesis portion. Like benzene is a primary reactant, or next that is a urea. This benzene and urea combine and form phenytoin. So basic structure, basic schematic representation of this synthesis portion is this. So you just remember that. So now let's move to the next slide. So let's discuss about process of phenytoin synthesis. So in the first step of first, you have to take 5.3 gram of benzene in a conical flask and add 8 gram of urea, followed by 1.5 to 2.5 ml of 80% sodium hydroxide solution or 75 ml of alcohol. So add this all chemical in a conical flask or reflux or dissolve it in a proper way or accurately. So how can you prepare 80% sodium hydroxide solution? You just have to take 80 gram of sodium hydroxide by weighing it on a weighing machine, and dissolve it on 20 ml water. Make their volume up to 100 ml. You will get 80% of sodium hydroxide solution. After their dissolution, you just add this to the benzene and urea containing conical flask, and add 75 ml of alcohol on that. That is a 75% pure alcohol. After their dissolution, the content were mixed and heated in a water bath for the 90 minutes. After the heating, you just have to cool down this container or this mixture of solution under water or tap water. And after that you just have to dilute this with 25 ml of cold water. Allow it to stand for the 15 minutes, then acidify it with the concentrated uh, uh, hydrochloric acid. So after its acidification, you will get a white precipitate or solid substance that is insoluble in water. Uh, what you have to do next? You just have to filter out this white precipitate or solid substance. After the separation or filtration, you just take it in a conical flask and dry it on oven and for the 10 minute or 15 minute in 120 Celsius temperature. After their drying, you just have to calculate a weight on a weighing machine, and there you just have to calculate their percentage yield and their melting point. So you just have to perform their melting point determination by various instruments, like automated system or another. That is a physical way in which you are going to use paraffin liquid for the determination of this phenytoin's melting point. So now let's move to the calculation portion. Or so in the calculation portion, as you all know, the calculation can be done by the correlation with the initial product. है ना? So here the initial reactant, that is a benzene. So 210 gram of benzene gives 252 grams of phenytoin. So similarly 5.3 gram of benzene gives 250 252.27 gram multiplied by the 5.3 gram divided by 210 gram of benzene, and you will get the theoretical yield, that is a 6.3 gram of phenytoin. So this amount is a theoretical value. So after you getting this theoretical value, you just have to weigh out your obtain or practical yield, है ना? So whatever amount they are, है ना? So you just have to divide that amount with theoretical yield, multiply it with 100, you will get the percentage yield of your actual percentage yield, है ना? So in the result portion, just write the phenytoins was prepared and submitted, and its percentage was found to be whatever you amount you are found that, and you just have to mention that. है ना? So next, that is a melting point determination. Whatever amount or whatever melting point you found for this phenytoin, you just have to write that, है ना, on this result portion. So it's over from my side, this experiment, है ना. These are the various references. You can also refer that references a book, है ना. So for the further more study about phenytoin synthesis and preparation, है ना. And lastly, thank you very much to all of you. I hope that you all understand all the things, है ना.